Like I told you in our last lesson of class, we shall be talking about the radius of a circle of latitude. If you look at my diagram on the board, that is the Earth, that is the equator, and this is a latitude 60 degrees north. The plane of the latitude is parallel to the plane of the equator. I've already explained that. So you can see that, and again I told you that the distance from the center of the earth to any point on the surface of the earth is equal to the radius of the earth. So you can see that if O is the center of the earth and P is a point on the surface of the earth, of course lying on that latitude 60 degrees north, then OP is equal to the radius of the earth. So we can use capital R to represent that radius. But AP is the radius of the circle of latitude 60 degrees north. You can see it in the diagram. So very clearly, you can see that triangle APO, APO is a right angle. I mean, it's a right angled triangle. Triangle APO is a right angled triangle. By virtue of the planes, the plane of the equator and the plane of this latitude being parallel, they are parallel. So this AP meets the polar axis at angle 90 degrees, making triangle APO a right angled triangle. Now, if we represent this radius AP with a small r, then you can see that we can obtain a formula to calculate that small r. So, take note, please take note that it is angle P, well, let me call this point E. It is angle POE that gives you the name of this circle of latitude. Angle POE is 60 degrees. Angle POE is 60 degrees. That is why we are calling this latitude 60 degrees north. Please take note. This is how we measure and give names to the circles of latitude. From a point on that latitude to the center of the earth, what angle does that make with the plane of the equator? So you can see why we are calling this latitude 60 degrees because this angle POE is 60 degrees. That is why we are calling it latitude 60 degrees north. In a similar way, you name the other circles of latitude. Now, observe that because AP is parallel to OE, we have already said that these are parallels of latitude. AP is parallel to OE. And so, with OP, you can now see that angle APO. If angle POE is 60 degrees, then angle APO is also 60 degrees, being alternate angles. When two lines are parallel and a transversal cuts them, it gives rise to alternate angles. Angle APO and angle POE are alternate angles by virtue of AP being parallel to OE. And so, you will now discover that if we look at triangle APO, I told you that this angle here is 90 degrees. And so triangle APO is a right angled triangle. In triangle APO, we can talk about the cosine of this angle. The cosine of angle APO is what? Adjacent upon hypotenuse. Take note. In triangle APO, cosine 60 degrees is equal to adjacent upon hypotenuse. In triangle APO, cos APO is equal to AP over OP. The cosine of this angle is adjacent upon hypotenuse. That is cos 60 degrees is equal to R over R. Where R is equal to radius of latitude 60 degrees and R is radius of the earth. Cosine 60 degrees is equal to small r standing for the radius of the latitude 60 degrees over capital R, where that capital R represents the radius of the earth. And so, from this very equation now, therefore, small r is equal to capital R multiplied by cosine 60 degrees. In other words, the radius of the circle of latitude 60 degrees is equal to the radius of the earth multiplied by cosine 60 degrees. So generally, the radius r of a circle of latitude theta degrees, whether it is north or south, latitude theta degrees is given by R is equal to capital R cos theta degrees, where capital R is the radius of the earth. And so in any problem on longitude and latitude, if you are looking for the radius of a circle of latitude, it is simply given by the product of the radius of the earth and the cosine of that latitude. That is what we have discovered now. So if you are solving any problem where you need to calculate the radius of a circle of latitude, all you need to do is to multiply the cosine of that latitude by the radius of the earth. Now, we are going to look at a case of finding the distance between two places on the Earth's surface. Let us this time limit it to two places on the same circle of latitude and on different lines of longitude. I will show that by Now, assuming that, okay, sorry. The distance on the Earth's surface between two places, on the same circle of latitude, but on different lines of longitude. Let us take a very simple case. Let us again take latitude 60 degrees north. And now, of course, this is the prime meridian. The prime meridian. And this is a longitude east of the prime meridian, and this is a longitude west of the prime meridian. So suppose we call this longitude longitude 40 degrees east, and call this one. So this longitude, which is west of the prime meridian, let us call it longitude 20 degrees west. Now, if you look at the diagram, you will see very clearly that if we take points like B, P, C to be on the lines of longitude, including the prime meridian, P is at the point where the prime meridian cuts latitude 60 degrees north. That is the point P. B is at the point where longitude 20 degrees west cuts the latitude of 60 degrees. And C is the point where longitude 40 degrees east cuts latitude 60 degrees north. So very clearly, like I said, B, P, C, there are points on latitude 60 degrees north with A as its center. Of course, AB is center means that AB is its radius, AP is its radius, AC is its radius. Now, you will get a clearer picture of this by looking at this diagram. Look at this diagram. This diagram, this circle is not the Earth. This circle is latitude 60 degrees. That is, I'm now representing latitude 60 degrees north in this form, with A as its center. It is now easy for you to see very clearly how longitude 20 degrees west got its name. You can see it. Angle BAP, 20 degrees west. longitude 40 degrees east is angle CAP, 40 degrees. So very clearly, you can see the positions of B and C with reference to the prime meridian. And so, like we have already discussed, the difference in longitude between B and C will be the sum of the two angles, because the two places are on opposite sides of the prime meridian. So the difference in longitude between B and C is 20 degrees plus 40 degrees, that is 60 degrees, angle BAC. Now, let the radius of the circle of latitude 60 degrees be R. The distance between B and C is given by the length of the arc BC. The length of arc BC. The arc BC gives the distance between B and C along that circle of latitude. And the length of that arc BC is given by the angle which the arc subtends at the center of the circle over 360 degrees multiplied by 2 pi r, where r is the radius of that latitude 60 degrees, which we have already discussed can be obtained by multiplying capital R by cos 60 degrees. That is how we obtain the radius of a circle of latitude. You multiply capital R, which stands for the radius of the earth, by the cosine of the angle of that latitude, that longitude, that latitude. So, to get the distance or the arc between longitude 20 degrees west and longitude 40 degrees east along the circle of latitude 60 degrees north, to get the length of that arc, this is the formula. The arc BC is equal to angle BAC over 360 degrees multiplied by 2 pi r, where this r is given by capital R multiplied by cosine 60 degrees, where capital R is the radius of the earth. So this is how we can calculate the distance between two places on the earth's surface, lying on different lines of longitude but on the same circle of latitude. In our next lesson, we shall take some problems. We shall solve some problems as examples to either calculate the distance between two places on the earth's surface or any other thing. But in our next lesson, we shall solve some problems. But before then, I want to point out one or two things. And please pay attention to certain things which I want to point out now with regards to the earth lines of longitudes and circles of latitude. Now, let us take this as the earth. We are looking at the earth again. Please always bear in mind that the earth is assumed to be a sphere. A sphere is a solid, an example of a solid. Don't look at it. If you look at our diagram on the board, it will appear as if the earth is flat. It's not flat. What you are looking at, even if I look at the way I'm drawing it, if I'm drawing a solid, it's a solid. So that you have to imagine very clearly that the polar axis is not on the surface of the earth, it is inside the earth. Even though you will argue that nobody has gone inside the earth to check all these things, but we have to work on these bases so as to get what we want. The polar axis is an imaginary axis that runs from the North Pole through the center of the earth to the South Pole. So please see NOS as an imaginary polar axis inside the earth. Then with that in your mind, you can now imagine the equator dividing the earth into two halves or two hemispheres. One hemisphere to the north, the other one to the south. And I've already told you that the equator is latitude 0 degree. And the prime meridian is longitude 0 degree. The equator serves as point of reference for the circles of latitude. The prime meridian serves as reference for the lines of longitude. Always bear that in mind. Now, if we are looking for, let us take again latitude 60 degrees north. Take again latitude 60 degrees north and consider again two longitudes, west and east of the prime meridian. Suppose we call this suppose again we call this longitude 40 degrees east, and call this one longitude 20 degrees west. These are lines of longitudes. They cut this latitude at 2 points, which we shall again show with B and C. The lines of longitudes 20 degrees west, 40 degrees east. See where they cut the circle of latitude 60 degrees at the points B and C on the Earth's surface, because these lines of longitudes and circles of latitudes are imagine drawn on the surface of the earth. We are occupying the surface of the earth. We are not inside the earth, we are on the surface. So for somebody to move from B to C on the earth's surface, you are cutting across arc BC, which we have already seen how to calculate. Now, an extra lesson I want every one of us to learn is this: that arc BC on the Earth's surface is not the only distance that connects B and C. Please take note. This is what I want to add to my lesson. The arc BC on the Earth's surface is not the only distance between B and C. You can easily see that we can draw a chord to join B and C. We can draw a chord. That is, I can do something like this. that is a chord, a straight line. But where is that straight line? Inside the earth. Are we inside the earth? We are not inside the earth. But it is equally a distance between B and C, only that it is inside the earth as a chord. I hope you get the picture of what I'm saying. Because what I'm saying is something like this. Suppose you have this as latitude 60 degrees. Let us say that the center of that latitude is, of course, here. Say it is at A. The radius of that latitude is this. R. And as we have already obtained, if you join these, that is, okay, call this point P to stand for the prime meridian. You have this now. P is there, B is here, and C is there. A is here. Please take note, this diagram just represents the circle of latitude. I have lifted it out so that you can see clearly the position of these places. So, as we are talking about arc BC being the distance between B and C on the Earth's surface, equally, this chord, you can see the chord now very clearly. That is why I have drawn this diagram. So that you can see the chord BC. You have to notice that the chord BC is equally a distance between B and C. But it is a distance inside the earth, and we are not inside the earth. But it is a distance. It can be calculated. We can calculate the length of BC as a chord. We can calculate the length of BC as a chord, if needed. We can. We can calculate the length of BC as a chord, if we need it. It is equally a distance between B and C. This time not on the Earth's surface, but now inside, and we are not inside the Earth, but it can be calculated. Now, if that is the case, you can easily imagine. Please take note, because I'm trying to make a very important point here, which is usually difficult for students to understand. There is still another distance between B and C on the Earth's surface. I want everybody to follow what I'm saying here now. There is still another distance between B and C on the Earth's surface. This time around, that distance lies on a great circle. Now, how do you get that great circle? As long as B and C are lying on the Earth's surface, there is a great circle that will connect them. How will that circle behave? Now, watch carefully. You now, if you join B to O and join C to O, what do you observe now? That BC subtends an angle at the center of the circle. Yes, it subtends an angle at the center of the earth. Now, if you complete the great circle, which will pass through B and C, but with O as center now, not A as center, but O as center, that distance between B and C on the Earth's surface and along that great circle is yet another distance between B and C, and it is usually shorter. It is usually shorter than the arc with the distance between B and C along that circle of latitude. By the time we solve some examples, you will get clearly what I'm saying. We calculate the distances. You will see that one is shorter than the other. Now, I'm making this point because in some problems, you may be required to calculate the shortest distance between B and C. That shortest distance is not the chord. It's not the chord. because like I said, we are on the earth's surface. We are not going to move inside the earth. But that distance, that chord, is equally a distance between B and C, but not on the earth's surface. The ones that are on the earth's surface are this arc BC measured along that circle of latitude, and arc BC measured along a great circle where BC subtends this angle at the center of the earth. So take note that arc BC does not only subtend an angle at A, which is the center of that circle of latitude, it can as well subtend an angle at the center of the earth by joining B to O, C to O. This is very, very important. Very, very important. Like I said, it will help us to calculate. We can calculate this angle. We can calculate it. Possibly by calculating the chord, the length of the chord, BC, we can as well. Because OB or BO and CO, each of them is the radius of the earth. Remember I told you that the distance from the center of the earth to any point on the earth's surface is equal to the radius of the earth. So as long as B and C are points on the surface of the earth, BO is equal to CO and is equal to the radius of the earth. So you can now see that if we know BO and we know CO and we know maybe the length of the chord BC, we can calculate this angle here. Let me call the angle theta. From the diagram, theta is the angle which chord BC subtends at the center of the earth. Theta, that which is the angle BOC, that is angle BOC. Well, I have taken this extra step so that you now know that it is not only the length of the arc BC on that circle of latitude and on the earth's surface that you can calculate. You can as well calculate the length of the chord that joins B and C. You can as well calculate the arc that connects B and C, but this time on a great circle. That great circle has angle theta at the center of the earth, and that angle can be calculated. We can calculate that angle if we are looking for that length of distance again, but this time on a great circle. So by the time we solve some worked examples, which is going to be my final treatment of this topic, we are going to solve as many examples as possible. You will see the importance of what I have pointed out to you now. So with this, I thank you very much for the treatment of this topic, the earth, longitude and latitude. May God bless you.